Okay, so I filled out the whole top section just so you can double check and see if you got these answers right. You can pause the video and just go through each one to make sure you understand how all these happen. For example, I'll just do F just to show you the process. It's like Simon said, CB over CG. CB, CG, the other side would be FE, FG. Okay, so that's the process you use to do that whole top section. So you can pause and go back and watch how to do those. Now the bottom section, with the middle section number 2, I have them all set up. Those are pretty straightforward. Side splitter theorem, part over part equals part over part. C was the only one that looked a little bit different because it gave you an entire X. So it's green over blue, green over blue. X over 8, 20 over 10. The bottom section, the first 2 are straightforward. Pause the video anytime. And then G is again like that last one, where it is blue over pink, part over whole, part over whole. There's other ways to do it, but that's the easiest way. As long as you stay consistent after the first part, blue over pink, then you just do blue over pink again. Letter H, just like the other night on the homework, you can't do this until you know that blue value 5 right here. The only way to figure that out first, you would know you're missing a number that you needed, is to do Pythagorean theorem. So 3 squared plus 4 squared is a right triangle, so you can figure out that that's 5. Once you know that it's 5, you have 4 over 7 equals 5 over y. Side splitter theorem, because these are parallel, because of the right angles. Angle bisector theorem are pretty straightforward. Boom over boom, boom over boom. Same thing here, you can turn it upside down if you want, you don't have to. X over 8, 6 over 10. Alright, the next page. This page focuses on the fact that you cannot use the side splitter theorem because the bottoms are labeled. So you don't have the sides. You have some sides, but then you have the bottom. So in this case, you have to redraw the entire triangles. There should be 12 and 14 for the small one, and 15 and X for the large one. This one's just kind of a trick question. Because these two are marked congruent, that means that the entire side here would be twice as big as either one of the halves. So if the entire thing is twice as big as the smaller triangle, then the bottom would be twice as big as the middle. It's kind of a proportion thing. This one here is another draw both triangles. I drew the small one, X and 4. I drew the large one, 6, 7, 5, and 13 all the way across. On the bottom, the last 3, I redrew the triangles again. The small one is 18 and 20. The large one is 18 plus X and 25. The angle bisector theorem here. If both of these are the same, then both of these are the same, right? No need to set up a proportion. If you wanted to, you could, but 7.5 over something is going to be the same thing over that same thing, right? It has to be equal, so that's why X would be 7.5 on both sides. This one's pretty tricky. Again, you're missing a number. You have way too many variables. So when that happens, you'll probably have a right angle. The right angle means you can use Pythagorean theorem down here. And the Pythagorean theorem, if you do the entire triangle, you would have had to see this, which is tricky. The entire thing would be 8, 15, and blank. So 8 squared plus 15 squared equals c squared. You can see the Pythagorean theorem there gets you to 17, which means the entire hypotenuse of the really long side here is 17. Then you can use it to do the side splitter theorem. You can do 15 over 17 equals 5 over y. Solve from there. Rewind, pause, watch again, figure these out, and I'll see you Monday.